Okay, for Algebra 1 today, we're going over lesson 2.6, which is about rates, ratios, and conversions. Right? Rates, ratios, and conversions. So, first thing we're going to talk about is a ratio. Right? What? No, that was good. First thing we're going to talk about is ratios, which are when we compare two numbers by division, right? And this isn't the first time we've talked about it, is it? Ratios. I mean, you guys have heard of this in middle school, right? Yeah. So it compares two numbers by division, right? And when we compare two numbers by division, how can this be written? It can be written in three different ways, right? How can this be written, right? Yeah. So like we have like 2, let me say dot, dot, 3, right? It says, and we read that as 2 to 3, okay? Yeah. 2 over 3 means the same thing. Any others? Of is the wrong word. We don't want to say 2 of 3. But we want to say 2 to 3. Okay? The word of means a little bit different, right? It says two, so if we said 2 to 3, that would mean like if we were talking about girls to boys, right? So you have 2 girls for every 3 boys. Okay? So it means like you have 5 students total, right? 5 kids total. If you said 2 of 3, it means you have 3, and of those 3, 2 of them are girls. So there's 1 boy, right? So those definitely mean different things. So let's make sure that we say 2 when we're talking about ratios. All right? Good. Most of the time in math class, all right, we're going to be using this middle one with ratios. Okay? The other 2 ways are used mostly in like a reporting or when you're writing a paper about a ratio, you know, like if you guys were writing a super official article for the newspaper talking about how many students are there per teacher, right? You might say there's, you know, in here there might be 28 students for 1 teacher, right? But we don't really do math with that, right? It's just kind of a way to show it without doing math with it. Does that make sense to everybody? Okay. A rate. A rate is the same thing as a ratio, but it compares different units. Okay, what's a unit? Special type of number, though. 5 is a number, but 5 is not a ratio, or 5 is not a unit. Yeah, anything that has a measurement to it, right? So anything with a measurement to it like feet, inches, yards, centimeters, meters, kilometers, miles. Is there any others besides distance? Yeah. What? Kilograms, cups, pounds, ounces. Those all deal with weight or volume, right? Net force. Net force. Force would work, right? That's a unit, right? Well, actually, force it'd be newtons, right? Newtons is the unit. So newtons would work. Talking about force. What about like electricity? What does electricity have? Watts, right? Watts is volts, amps, right? Those are all parts of units which can make a ratio. Okay. Some ratios that your parents might use, right? I know my dad did this when I was growing up. Every time we went and got gas, right? He had like a little notebook in the glove box, right? And he'd pull out the little notebook and he'd write down, you know, like, I don't know, 320 miles. And then what would he write down? How many gallons he's bought, right? And then you write down, and this was from, we'll say, 23.2 gallons, right? Is that a rate? Does it have 2 different units? Yeah. So it's a rate. No, it has to be different units, right? Different units.
What if it was just 1 rate?
So if it was the same on top and bottom? Does not count because you can't say, they should be different units. I know sometimes, kind of depends. Like you can have with the same rate, but be kind of like, or the same unit, but might be a little bit different. Okay, and let me give you an example. Okay, now you are in a race with Ulisa. All right, so you guys are having a race. After, like, if I say 10 seconds, all right, let's say that Ulisa's gone after 10 seconds 100 yards, right? And you've gone 50. You're slower. Okay, 50 yards. Right. I guess I would count that as a rate. I don't know if technically it would count as a rate, but I'd count it as a rate because of its like Ulisa's yards and your yards. Okay, so I think I'd count it different. But as far as the book goes, it says different rates or different units, right? So. Okay. Now, last one we're going to talk about is a unit rate. Last one on this slide. There it goes. Is a unit rate, which is the same thing as a rate. The only difference is the bottom number, the denominator, is 1. This unit rate is way more useful than a regular rate. Okay? Because if I look at this rate here, which my dad does for gas, right there. Why is he making that rate? What is he trying to find?
How many miles per 1 gallon?
Yeah, miles per gallon, right? And does it tell you how good of gas mileage you're getting if I told you, hey, my truck gets 320 miles for every 23.2 gallons? No. It does not make sense to us, right? So what we want to do is we want to make it a unit rate so it makes sense, right? And how are we going to do that, Stephen? Yeah, we're going to do the division part, right? And we're going to get a special number, right? So does anybody got a calculator right now? You got it? What'd you get? Okay, so 13.79 is what we got after we divided. Then we write the back half as, see, since miles is on top, we say miles. How do I make, what letter do I use for the division sign? Don't know. Does anybody know? P for per, right? The division signs, right? It means per, right? So this is miles per gallon, right? MPG. That's how many miles per, or that's 13.79 miles per how many gallons?
1 gallon.
1 gallon, right? And that's the unit rate, right? 1 on bottom, right? So we want 1 gallon. Okay. 13.79 miles per gallon. Is my dad's truck very good? That could be better, right? 14 is not the best. All right. All right. Everybody got that down? Yeah. Okay. Here's problem 1. We have 3 different stores that are selling T-shirts, right? And you're trying to do the best school shopping that you can, right? You want to get as many T-shirts as you can for your summer money, right? Everybody in here has a summer job, right? You guys don't have summer jobs? Yeah, you better get summer jobs. Don't be just sitting around playing Call of Duty all day. That's ridiculous. Okay, so what we want to do is, because if you make your own money, you realize that making money is hard, right? And you just don't want to spend it on whatever. So you want to get as many T-shirts as you can for your money, all right? Now, first off, let's put, are these 3 stores with the dollars in the shirts, are those rates? Could we make those into rates?
Yeah.
Are they both units?
Yeah.
Yeah, we have dollars and shirts, right? So they're both units. So let's make each one of these into rates, okay? Eric, what's the rate of the top one? You don't know? What? That's right, but I'm going to write it out the long way first, right? You went automatically to unit rate. I'm going to write it down as my rate first, right? This is $25 per 2 shirts, okay? Ashley, what's the middle one going to be? You don't know? Well, let's look at the top, the one we just did, right? Where did we get this 25 from? I'm asking Ashley. So we got this $25, right? Does it look like that right there? So on store B, what's going to go on the top of the fraction? 45. And the bottom is going to be what? 4 shirts. All right, Eric, store C. Okay. Now we have them all in rates. But if I look at those, do we know automatically which one's best?
Yes. I do.
You guys know, but you did something in your brains. Do we know just by looking at those ones which one's best?
No.
Right? I know some of you guys were doing something in your brain. What were you doing in the brain? You were making them into what? You were changing them from a rate to a what? Unit rate, right? So we divide. Takeda, so this is 12.5, and this is dollars per shirt, right? Good. Store B, let's ask Alex, how am I going to find out store B? What do you need to do? Divide them, right? And then somebody's got a calculator. Eric. 11.25, and we're talking about dollars per shirts, right? So store B is the best one, right?
No.
Oh yeah, we didn't compare them all. So let's go to store C, right? We'll ask Carlos, what am I going to do? Divide it, right? And what do I get? 10. So I get $10 per shirt. Which one am I going to pick?
C.
Store C, right? I'm going to be saving money that way. Good.
You buy 5 shirts for the price of store A. Huh?
Yeah, if you buy 5 shirts at store C for the price of 4 shirts at store A.
Yeah.
Oh, okay. So, what's his face over there, Alcadio, says at store C, if I bought 5 shirts, right, if I had $50, I'd get 5 shirts, right? Now he says if I have $50 at store A, I'm only going to get 4 shirts, right? You get an extra shirt for shopping at store C. Okay. Does anybody do this when they go to especially like Safeway? Does anybody do these? You do that? Does anybody go around and you're like, we'll say you're in the soda aisle, right? And you're trying to think, you're like, man, should I get the 6-pack of the tall ones, the tall bottles, right? Or should I get like the 12-pack of the cans? But Safeway does something really nice for you. What does it do?
They give you a discount unit rate on the thing.
They give you the unit rate right on the tag, right? And what is that unit rate for like soda?
How much an ounce costs?
Yeah, how much an ounce costs? So it'll say like maybe for the bottles.
43 cents an ounce.
Yeah, for the bottles, usually it'll say something like, I don't know, 5.3 cents per ounce, right? So that means for every ounce you drink, you're paying 5.3 cents, right? And then maybe we have the 12-pack of cans, and it might say like 4.7 cents per ounce, right? Which one's the better deal? The cans, right? The cans are the better deal.
It depends on how much ounces it has. Yeah, because the bottles can be really long, and then the other ones are short and stubby.
No, that's true. So you're saying that the bottles, they since they're really tall, they hold more, so they're a better deal, right?
No, but then the other ones are fatter. Yeah, okay, so now we have to figure out.
Now, what we've done here, because of they have different costs and they have different volumes, right? I think if you bought 12 smaller cans, it would be more soda than if you bought 6 taller bottles, I think. I don't know, how tall are those taller bottles? Like 16 ounces or 20 ounces? So there's going to be more soda in the cans, right? But doesn't mean, what we're looking at, if it tells me 4.7 cents per ounce, right? That tells me for every ounce I buy, I'm paying 4.7 cents. Doesn't matter how big the bottles are or how small the bottles are. It's just telling me how much each ounce costs. I might be buying more soda, but the soda is cheaper per ounce. All right, does that make sense to everybody? Okay. And usually with stores, how do you make it cheaper per ounce? How do you do that? Coupons will help. But in general, which ones are the cheapest? So say that again?
Like if you're buying like bottles and cans,
Yeah.
bottles have more soda in them.
Yeah.
More food left than your food.
Okay, so that's right. Usually, they give you a discount or cheaper price if you buy more of it, right? So if we say that we're buying a whole bunch of cans and there's more total, right? Not more cans, but more total soda than the bottles. Usually, the more you buy, it's going to be cheaper. Does anybody here go with their parents to Costco? Why is Costco so dang cheap? Because you buy barrels of ketchup, right? You buy a whole big barrel, you don't need to pay as much per ounce, right? Okay. All right. Next, we're going to talk about conversion factors, okay? Conversion factors we're going to use to change from one type of measure to another type of measure, okay? So this is a ratio of equivalent measures on different, I don't know what I meant to write there. I didn't finish it, did I? Ratio has two equivalent measures in different units. Somebody must have come and bugged me when I was writing that because I didn't finish it. Okay, so different units. All right, so let's come up with a ratio, right? That's the, right? I need two different units that mean the same measure. Okay, does that make sense to everybody?
Yes.
So let's go, Lacey, give me some type of unit. A unit. Numbers aren't units. What are units?
Measurements.
Measurements. So give me a type of measurement.
You said it. Feet.
Yards, okay? So yards. Okay, and I'm going to say 1 yard, okay? Now, 1 yards. Now, we want to come up with a second one, right? We need two that are equivalent, all right? Noah, give me an equivalent distance as to 1 yard. We're using different units. Feet. How many feet? How many feet? This is a conversion factor, okay? Is it the same distance on top as it is on bottom?
Yes.
Conversion factor, always the same on top as bottom, okay? All right, we're going to use this to solve some problems, okay? Oops. Here we go. So we're going to convert 330 minutes to hours, okay? 330 minutes to hours. So, first thing I want to do is I want to use minutes as a ratio, okay? So, I'm going to put in 330 minutes over, what can I put that over to make it a ratio?
60 minutes.
If I put it over 60, that's going to change the number. Do I want to change the number?
1 hour. No.
We're just going to put it over 1. Okay, we're not going to make it an hour or a unit or anything like that. I'm just making it a fraction, okay? Just making it a ratio. I'm going to take it and I'm going to times by my converting factor, right? My converting factor should have both what I currently have and what I want to change it into. What unit do I currently have? Minutes. What do I want to get it into? Hours, okay? Now, we need to put it in here a special way, okay? If minutes is on top, minutes needs to go on bottom, okay? If minutes is on top, minutes needs to go on bottom, okay? Somebody ask me why. Thank you. That's a great question. Okay. Because I don't want to have minutes at the end, right? I want them to cross each other out. Okay. And units reduce just like other fractions. All right. So let's say I have 2/5 times 1/2. What would you guys do if I was going to times those two fractions together? Yeah, I would say, well, this 2 crosses off with this 2. I don't need those anymore, right? What's going to happen to this minutes and this minutes? Cross out, leaving me with what?
330.
How many hours?
1.
Oops.
No, 5.5.
Okay. Now, I have hours on top, minutes on bottom. Now I need to come up with my equivalent measures, right? So, what type of equivalent measure do you guys want to use here? Nobody knows? How are minutes and hours related? 60 what? 60 minutes.
1 hour.
1 hour. Okay. Now that I have my conversion, my other ratio down there, then what happens to my minutes? What's the only thing I have left? The only unit I have left? Hour. 330 times 1 over 1 times 60? 60. Now, is this usually how I tell time? No. If you say to me, oh, how long before we get out for assembly? Do I say, oh, it's 330 over 60 hours? Is that what I say? That's ridiculous, right? All right. Dakota, what do you want to do? Divide it, right? Somebody have a calculator wants to do that for me? Yeah, you could. So then, if you cross off the ones, you're still left with 330 over 60, right?
But you wouldn't cross off the ones because one of them is not in H fraction.
Okay. Then we get 5.5 hours. Right? Question. I know right now it's going to be easy, right? But eventually we'll get into where it's going to be harder, where you're going to need to use multiple steps. So right now I want you guys to set it up, even though I know that you guys could probably do it without it. I want you guys to set it up so that you get into a good habit, okay? All right, 5.5 hours. Okay, now I'm going to go over to part B, so I'm going to erase this. Is that okay if I make some room? Okay, make some room. All right, so I have 15 kilograms. Okay. I need to make it into grams. How many grams are in a kilogram? That one's tough. All right. Now, we want to do what first? Okay, let's set it up first, and then we'll come up with the numbers in a second, okay? Steven. How are we setting this up? Okay, I don't know what you're talking about. But does anybody know what we want to do right now? I want to times by something. What goes on top?
The kilograms. No, the grams.
The grams. What goes on bottom? Kilograms. Let me ask Cameron, why does kilograms go on bottom? I can do the what? Yeah, right, cross cancel, right? So I want to cross cancel my kilograms, leaving me with only grams, right? Now all we need to do is know how many, what's my numbers that go in here, right? Does anybody know? Nobody knows? I know that, okay, how about I tell you that kilogram goes there. Grams and kilograms, they're in metric, right? Which means that they are all related in multiples of 10, right? So either 10, 100, 1,000, right? So there's 1,000 grams in a kilogram, all right? What happens to my kilograms? All right, multiply, I get 15 times 1,000 is what? I'm left with grams, so I get 15,000 grams. Okay, Eric. Yeah, I don't know if there's any in your books. If there's not, then I'll get you guys something that you guys can have, okay? All right. Now, when we talk about metric, right, kilo means how many? 1,000, right? So a kilogram has how many grams? 1,000, right? A kilometer or kilometer, right? A kilometer has how many meters? 1,000, right? A kiloliter has how many liters? 1,000. A kilowatt has how many watts? 1,000, right? So kilo means 1,000. Kilo means bigger. Kilogram is bigger, right? If I take something small and I take 1,000 of them, I got more than I started with, right? Okay? What? All right, I got that. So Steven says kilo has an O right there in the fourth spot, right? So that means that I'm going to have 1, 0, 0, 0, right? Kilo has an O in the fourth spot, so we're going to have 4 numbers, right? 1, 0, 0, 0. Okay, kilo. Was there a question? Somebody had?
I don't understand what you did.
What?
Is there anything else like that?
There are other things like that. All right? For example, this is 1 meter, right? What are these little numbers right here called? Centimeters, right? Centa means smaller, and how much smaller? How many centimeters are there? Well, there's 10 centimeters right there. 20, 30, 40, 100, right? How many centimeters are in 1 meter? 100. How many centiliters are in 1 liter? Or I mean, yeah. How many, well, I guess you could do centawatts, although that's pretty small to begin with. Right? But centa means there's 100 parts to it. All right, so here we have a tower. Tower in Toronto, Canada. It's about 1,815 feet tall. We want to know how many meters tall is it, assuming, and they say use the fact that 1 meter is 3.28 feet. Okay? So I'm going to take my tower. Times, right everybody? Times. What unit is going to go on the top of my ratio? Iris. What unit is going to go on the top of my ratio? Well, that's not a unit. Unit means like I want meters, feet, gallons. Those are units, right? So what unit's going to go on top? Too long. Alcadio.
Meter.
Meter. Why is meter going to go on top, Alcadio?
Because 3.2 feet is bigger than 1 meter.
That's incorrect. Hannah, why do we put meters on top?
Because so the feet can go on top,
So you want feet on bottom. Okay, what's special about that?
so they can
Cancel out, right? We want the bottom feet to cross off with the top feet, right? We want those two to cross off, leaving us with only meters, okay? All right, Iris, how many meters do I have? One. What about feet? How many feet do I have? Now what do I need to do, Jessica? Yeah, well, I'm going to do it long step, right? You know that you're going to divide it, but I'm going to work it out long ways, okay? So I'm going to say, well, this is going to be 800 or 1,815 feet over 3.28, right? And no, we have meters, right? So that's the long way. And then we need to divide that, which we get 500 something? Like that? Okay. So we get about 550 meters. All right, 550 meters. Any question over that one? Okay. Okay, here we have a student ran the 50-yard dash in 5.8 seconds. What speed did the student run in miles per hour? Okay. Now this is one of the ones I told you that more than one step. Okay. So we're going to want to keep our steps written down and everything. So right now I have yards and seconds, right? Which one do you guys think should go on top? Yeah, the yards, right? So 50 yards over 5.8 seconds, right? Now, I think that naturally that feels better to us, right? Because we think about miles per hour. We think about, feet per second, right? So the distance will go on top. Then we need to change this, right? Our final answer we want to have in miles per hour. Ew, right? Ew. Because we're changing both now, aren't we? So this is going to take more than one step, okay? More than one step. We're going to have to change one unit first, and then the second unit, or the other unit second, okay? So let me ask you guys, which unit do you guys want to change first, yards or seconds? Yards. Okay, I'm hearing yards, okay? Does it matter? No, as long as you keep the steps right and you don't break any math rules. Okay. So I want to change yards to miles. Okay? Do you guys know how many yards there are in a mile?
200.
Is that just a guess?
Yeah.
That's not right.
Wait,
Okay, how many yards in a mile? Does anybody know how they'd figure that out? How many feet are in a mile? Actually, I'll do it. So we know 5,280 feet in a mile. And we know there's 3, so we're going to divide. So we're going to get, so that's 1, we get 22, so that's 7, and we get 18. How many yards? 1,760. Where are we going to put that 1,760? On the bottom, right? Right. What's going to go on top? Miles, right? So we're going to have how many miles? 1, right? Now, this is how, which way do I want to show you guys? I'll show you guys piece by piece way first, okay? So now I want to say equal, right? I want to figure out where I'm at right now, and then we'll move on from there, okay? So I know the yards and the yards cross off, leaving me with 50 times the 1 on top, over 5.8 times 1760. I need somebody with a calculator. 10,208. Okay. We still have a speed here, right? The only difference now is we said if that person ran continuously, they'd run 50 miles in 10,000 seconds. Right? Right? Which doesn't make a lot of sense for us yet, but are we done with this problem? Okay. So I'm going to take what I have right now. Oops, not equals. And we need to do this again, right? Which one do I want to change now? Seconds. So I'm going to take this, I'm going to say times Iris. Where am I going to put seconds at? On the top. Why? I want to be able to cross them out. Where's this seconds at? Where are these seconds at? Top or bottom? See, this is seconds, right? So is this on top or bottom? Bottom, so this one's on top, right? We want them to be opposite each other. Okay? So, and then on the bottom we want to have what?
Minutes.
Hours. All right? All right, how many seconds are in an hour? You guys are wrong. There's 60 seconds in an hour?
170.
Nope.
60 times 60.
There we go. All right, what happens to the seconds in the seconds? Cross cancel. Giving me, I'll do the hard part. You guys do the easy part, okay? I'll do the bottom. There you go. You guys do the easy part, which is the top. Huh? So the top's going to be miles, right? 180,000? 180,000 miles. So if that person kept on running for 10,000 hours, they would go 180,000 miles. But is that the way I talk about speed? No, we like them in what type of unit rate? So what am I going to do to these numbers? Divide the top by the bottom. Somebody with a calculator do that. And over here I'm going to say miles per hour.
Equals
17.6 miles per hour. Do you guys think that's good? You guys think you can beat that?
No, it's 18 miles per hour. This is the nearest tenth.
This is the nearest tenth. That's a tenth. That's a one. No, this is a tenth. If they said to the nearest whole number, you'd be right. All right, so 17.6 miles per hour. Okay? Be ready. I think tomorrow we might try to beat this ourselves. Okay, this is our homework assignment. Okay?